Hey everybody, and welcome to another Microchip live stream. My name is Matt Dickens, and I'm here with a couple of my partners today. We have Kurt and Bill. How you guys doing today?
Morning. I'm doing great. How are you doing?
I'm doing good. I'm excited for another.
Morning, Bill.
Morning, Kurt.
All right.
But yeah, no, I'm excited for another great live stream. We're going to be talking a little bit about graphics today. So welcome to how to enhance your product with embedded graphics. Kurt, Bill, who are you? Tell us a little bit about yourself.
Hey, my name's Kurt Parker. I'm a product marketing manager with Microchip in their 32-bit microcontroller division.
Okay.
And I'm the PMM for our graphics
Cool.
chips.
Yes, and my name is Bill Lee. I'm the applications lead for MCU 32 division specialized in Harmony graphics.
Awesome, awesome. So you make things look pretty, and you're the smart one. It's kind of what I'm hearing.
Yeah, that's about it.
Awesome. I'm in marketing too, so I can say that. Before we get started, I'm going to send you back to the booth, and Rachel and Clifford are going to tell you a little bit about how you can get involved today.
Hey, Matt.
Hello, hello.
So my name is Clifford Swartz. I've been on the live streams a couple times. Very happy to be here.
Yes, and I am Rachel Bedore, also returning. And yeah, we're excited we'll be monitoring all the questions. So if you have one, just put it into the chat, and we will do our best to make sure that everyone gets their questions answered.
Absolutely, and if we don't get to actually answer your question, make sure to email us at livestream@microchip.com. And in addition to this, we'll be giving away a prize. Rachel, could you tell them a little bit about that?
Yeah, so we'll be giving away the PIC 32 MZDA starter kit. They'll show it up on the stage in a second, and it has the multimedia expansion kit. It's actually a pretty valuable prize, so we'll only be giving away one. And to participate, just participate in the chat, and we'll add your name to a random drawing, and then we will draw it at the end.
Yep. Back to you, Matt.
Awesome. Thank you, Clifford. So, Kurt, Bill, we're talking about graphics today. I think the first big question that I had when getting started on my own and other people have is, why do I even need to take the time and the money and the energy to try to implement graphics in my system?
So, Matt, it's all about the user experience.
Okay.
You want to have your system generate the most positive, best, happiest user experience possible for that end user. Now, because they're going to have that great user experience, because they're going to see your great graphics on your device, first of all, then your device is going to be more recognizable. They're going to be able to pick it out from a crowd. They're going to be able to easily see before even getting hands on it that your device is going to be useful. It's going to help them. It's going to meet their needs, and it's going to give them all the information that they need from using whatever you create. Now, the other part of it is you want to drive preference. If they're enjoying your device, if they're having a good time with it, or they're useful with it, they're efficient with it, they're going to remember that experience. Because your user interface, because your graphics will tie into everything else about your company and your product, all the colors and logos and everything else, they're going to tie that positive experience to your brand. And because they've tied that positive experience to your brand, they're going to seek out your brand more. They're going to look for ways to engage with it more. They're going to prefer to buy products from your brand and your company versus other companies. That's going to mean more sales. That's going to mean more revenue. That's going to mean more profit. And it's going to mean a higher profit margin because people who have a preference are willing to pay more for your device than for any other device in a similar situation.
Great. And those are all important reasons for sure. So then once I've kind of figured out why, I think really where the nitty-gritty of what we want to talk about today is how. So when I get started working with embedded graphics, kind of what are some of the challenges that I might run into, or what are some of the walls that I kind of have to scale before I get to a finished product that's really going to help improve my brand and my logo and all those kind of stuff?
So Matt, the first thing that we hear from customers is actually the first thing. It's where do you start? So having a great place to start, knowing where to go and what to do right from the beginning makes all the difference in how well you get started out. So Bill, talk to us about how important it is to get started on the first step.
Most certainly. So fundamentally, let's start off with right from the start. What is graphics? I mean, graphics fundamentally is shapes, images, some text, all kind of grouped into what we'd call a graphics user interface. And that together is what contributes to what what you're talking about, the good graphics experience, right?
A GUI,
Yeah,
graphical
a
user
GUI.
interface. A GUI.
Exactly.
All right.
So, but the graphics on its own is never, you never just do graphics for the sake of graphics. You never just have this as, it's always working to interface with some sort of application. And oftentimes, we're, especially in the embedded industry, most of our customers already have a successful product. They are trying to add add to the value of the product by adding this graphics user experience, this new graphics user interface for that better experience, right? So in that sense, most of most of the customers we deal with, especially the ones I've interfaced with, they have a product and they come from a space where they're used to the embedded world, but they're not necessarily comfortable with graphics development itself. So with that in mind, they're thinking, oh, well, maybe I need to learn some rocket science or something advanced to do this. But given the right tools, I think you and I can both agree that it's not that hard, actually.
You don't have to have a degree in graphics design in order to be able to design graphics.
Not at all.
Great.
So one of the other things, once you get comfortable with an understanding of where to start, and that you can actually start, you don't have to go and learn a new degree, go back to college for it, is to understand the nature of the tools and the nature of the software and the nature of the demos that you're going to be working with. And one thing to keep in mind is that if you are not working with the tools and the software from the manufacturer of the equipment, the hardware, the silicon, then you have some potential roadblocks. It has the potential to slow you down, doesn't it?
Yes. So let's go back to that example of we have a customer, and I'll go into a little more detail. I actually had this customer where he has a successful product. He's selling a scale, an electronic scale for grocery stores. He's been selling that for years. You put something on. He's got a little bit of a LED display to show,
like a segment display,
yeah,
right?
a segmented display to show the weight. But now he wants a capacitive touch. He wants almost like an iPhone experience where it's showing pretty pictures of the products. It's showing a price, and he wants this nice interface to this, right? But guess what? Why is he doing this? It's because he actually has a competitor that already has a similar product.
Right.
So, and his competitor's product is already out in the market. So he needs to add this really fast.
Getting back to what you said before about the perception of value from their customers.
Exactly.
They see the other one is more valuable because it's got a nicer display.
Precisely. So that means he's got to get his product out fast. We're talking about time to market. Very important, right? So time to market means the moment he decides, okay, he needs his graphics to the point where he has a working product, all that development time, the shorter it is, the faster he can have his product out there to compete with his competitor. So in that sense, having the right tools, the right development environment, all that helps him to shorten that time to market. And if you can bring up the slide number 2 there, Matt. Yeah. So here is an example of how we actually bring graphics from nothing into to adding into application, right? Typically, you have some sort of what you see is what you get the designer tool that starting from the blue section there. You need to add in the text, the fonts, and oftentimes it's as I mentioned, some sort of images or some shapes. You're adding these assets into the design. Then you take that design and you group them into certain screens, logical screens for this user interface environment. And of course, you need this graphics to interface with things underneath in the IOs, the peripherals, the actual application itself. So that's where the event handling comes in. And then as part of that development, there's a display involved. There's some drivers involved you got to write some drivers, the customer's got to write some drivers for that display. And to combine all that, we're all talking about coding here. So some sort of C code the design itself would be in C code, the drivers would be in C code. All that needs to be integrated with the application, and oftentimes it's already an existing application. And then all that goes in to the runtime portion of it. This is where we actually put this on the hardware. Within the hardware, typically there's some sort of a graphics library, a graphics engine that takes this design and converts it into what we call frame buffer data, pixel data, in which the driver now at the runtime level drives this into the display. And then lastly, of course, we put this on to the device itself for qualitative evaluation. All this we would call a development iteration. Now, notice I use the word iteration. Why? Why is it an iteration? It's because it's never once. You never develop graphics
Well,
once.
when I develop graphics, it's always the first time, right? No, I'm just kidding.
We're the exceptions to the rule here at Microchip.
Yeah, exactly. So it's an iteration, which means and it's never once. In order to develop a professional user experience, oftentimes you're doing it over and over. It might be, that button I have on screen, it's a little off. I need to move that 5 pixels to the right. The font, that's probably not the font we license for, or the branding is not quite correct. So we got to change that font. And then, well, how about this? What if you're deploying your product for multiple markets, right? So you're not just dealing with a single language here,
right?
Okay, so you might have developed your product for that first language for that initial market, but now I need to sell this to Asia Pacific. I need to sell this to Europe. I need to sell this to Eastern Europe, or maybe in the Middle East. Like there's different regions, they use different languages. So now you got to do all these changes too, and if all these are iterations, and then and the longer the time it takes for each iteration, the longer the time for development, the longer for the time to market.
Right.
And inversely, the shorter you can make this, the faster you get to the time to market.
Time to market is not your friend if it takes too long, right?
Right. Well, speaking of time to market, or maybe not, I think we got a question in the booth.
Yes, we do. Rachel, what is the question?
So Billa Prakash is asking, what is the basic board that I can start working on with embedded graphics?
Great question.
Yeah,
It's an excellent question.
Yeah.
So I think part of that depends, Bill, that what type of graphics you're looking for, what resolution you're looking for, how many colors you're looking for, the size. So I think later on we're going to go over the various different areas, but as you're going to see coming up, it's important to be able to not have to move around tools too much when you're trying to evaluate what level of graphics you're trying to implement. So a lot of variables in there, not sure where you're at, but stay tuned. We're going to cover how to deal with the various different levels of performance that you're looking for.
Yeah, great question, Bill.
Yep.
Thanks.
Thank you. Stay tuned.
All right, awesome. So I know we've talked about how do you get started, knowing the tools and demo applications. So what else are there to keep in mind as you're working through the different challenges? So
that question was kind of a great lead in, because yes, we've talked about where to get started, and that the fact that you can get started. We've also talked about the tools and the demos and the applications and where to get those. The next thing you want to take a look at and know what you're getting into is the hardware. It's going to make all the difference to have hardware that you can work with, or it's just going to bring you to a crushing halt if you're working with hardware that doesn't work together, that's not modular, or isn't well supported by the software tools that you've chosen to use. So talk to us about what's important to look for in hardware.
So I think as I kind of lead into this question, we can probably answer Bill's question along the way here. So when we talk about good hardware, development hardware, we want easy entry, as in something that they can pick up easily enough, and scalable. Why? Because maybe we can start them off at a more basic level, or maybe the customer, especially if we go back to the scale, our customer with the electronic scale, he might have a 7-segment display. So now he's going from 7-segment maybe to an OLED black and white or something like that. Some maybe something a little bit more sophisticated than what he had before, or maybe just a smaller 16-bit, 65,000 color display, something along that line. So that's where the scalability comes in. Then you got to look at modularity. Why is modularity important? Well, maybe he's looking at offering different products with some with a smaller display, or maybe a higher end product with a larger display, but it might be the same development software. So that's where the modularity comes in, which brings into the versatility of it. And Matt, if you can bring up the slide number 3. Here is an example of, and these happen to all be Cortex core, ARM-based Cortex core products. But as you can see, there's a development board. Typically, like all four of these, you see a development board, and then you also see it connected to a display. This is what I'm talking about when we're talking about modularity. That those ports can be mix and match to the different displays. Of course, it depends on the capability of the core to support this. So for example, you have the M0 device, which is driving a lower resolution OLED display, and it actually utilizes external controller, an external graphics controller, as in there's a separate device that drives the display that the core is communicating with. Then we have the M4 in the second one there. That is driving a slightly larger display. It's still relying on the external controller for the performance itself. This is typically in the industry what we call a smart display, where the external graphics controller is right as part of the display itself.
Just so we know, though, that external controller,
Yes.
it's not, I mean, it's controlling the display, but it's not creating the data. When you talked about the various levels of processor, it's important to choose the right processor display combination, because that processor is actually doing what's called rendering.
That's right.
It's creating the data that is actually going to be in the display.
Yes. So, and there's multiple ways for the device, the microcontroller device, to actually communicate this frame data to the external controller.
Yes, right. But what's important there is that the external controller is just controlling the electronics of the display,
Yes.
not what's actually on the display itself.
That's right. All it's kind of a dummy device that's holding the pixel data, and it's constantly firing it into the display.
Got
itself.
it. Okay. Thanks.
Yes.
Thanks for the clarification.
And
on that.
going back to the slide there. Now we look at the third product. So with another way to manage cost is to actually find some way to remove the external controller itself. Since it's, as I mentioned, it's just a dummy device that's constantly firing pixel data into the display. So this is where we look at that third product, where we have LCC. LCC stands for low cost controllerless graphics.
Low cost and controllerless. Got it.
Essentially what we're saying is now the device has enough capability to do that dummy display driving activity into the display itself. So it does rely on the performance of the core, some of the capability of the core to achieve this, but it's an alternative. Like if you have what we consider a medium performance level MCU device, running between 200 to 400 megahertz range, those type of devices. That kind of sweet spot is ideal for this kind of LCC.
And
approach.
our own testing has shown that the LCC approach takes about 5% of the processing power.
Yes.
So think of all the processing power of a microcontroller that would be in that 200 to 400 megahertz range.
That's right.
Being able to drive directly that display takes just 5% of that power.
Typically, 5%. That's about it. Because essentially, we're using the device's DMA capability to drive typically in a parallel mode, to drive these pixel data out to the display.
Direct
itself.
memory access.
Yes, direct memory access.
Yeah. Okay. Good.
Cool.
And then even more exotic at the even higher end level. And in this case, we have shown here in an MPU product, but this is where it's no longer an external controller or an LCC. It's a dedicated internal graphics controller, and so it as a peripheral as part of the device itself. So we have there's MPU products. As well as MCU products that all have this capability, and with that capability, you can actually do a lot more exotic, a lot more higher quality, higher performance graphics with that, and because now you have a dedicated peripheral that's doing that driving. You're not even using that 5% on the core itself, and the core can be the one that's busy drawing into the frame buffer, and then the peripheral is the one that drives out the display.
So it would be safe to say then, it sounds like what you're saying is, as I kind of back to the question originally that the user had, as I move up the ranks of kind of what I'm doing with the display graphics, I'm going to take more of the responsibility of creating the picture that's on the screen, and what the screen's actually doing, more of that responsibility is going to move from the core, so from the actual microcontroller, to the device itself, to the screen or display or whatever.
Not only is it more responsibility, it's more capability. So if you take a look at that slide, you'll see how much nicer, more colors, cleaner, and more dynamic the demos on
More
each of these
pixels,
pictures, more
yeah.
pixels, more
Larger
colors,
larger displays.
as you move up in performance.
Okay.
So it's more responsibility, but also more capability.
Okay, cool. Awesome.
All right.
So just to kind of then recap that section, if I'm going to have specific bullet points of things that I need to pay attention to as I'm kind of analyzing the different graphics options that are available to me out there, what would those specific design requirements or specific functions be?
So if you're looking for, what you should be keeping in mind when you're evaluating graphics design tools, first of all, you should expect to use, and you should want to use, because you're developing your device professionally to meet a target market, to dazzle your end user and hope they come back and continue to interact with you. You want to use professional, powerful, and innovative tools. So step one, make sure your tools are up to the task. You want to make sure that you're also using tools that are integrated or can be integrated very easily into the larger framework of the software and development tools that you're using. So as graphics is just one component of your overall system, going back to the scale example, you're still going to have your A to D converters and everything else that you need to actually take and measure a weight. You want to be able to know that your graphics tools are going to integrate with the software development tools that you're using to perform that function and create that function. You also want to make sure that it's easy to use. Ease of use is of utmost important, because as we've talked about all the way through, time to market is crucial these days. And if you're trying to use something with a huge learning curve, that's going to really stunt your ability to get out to market fast, or it's going to cause you late nights and lots of headaches and over-caffeination. One of those two, or both. But with all of those great things, you should also expect to be able to manage cost. Remember, if you're paying a licensing fee or you're paying a royalty per unit for development tools, that's going straight to the cost of your device to your customer. That is going straight to your bottom line. That is going to hit your company's profit margin. And so you want to be smart about how much you're paying for these tools. You want to be paying zero, right? I mean, zero is the best option there, but as low a cost as possible. And last but certainly not least, actually no, not last, but definitely important, is the documentation and where you can go to find help, to expand your knowledge, okay? Once you get working with it, once you get comfortable with the tools, you're going to want to know more. Because you're using powerful professional tools, you're going to want to use more and more of the capabilities of those tools. And because maybe you're expanding into those larger displays with more dynamic content, you're going to want to make sure that you're using the functionality of the tools that'll give you access to that functionality.
Okay.
And then as now last but certainly not least, you want to make sure that you're using, and we talked about this briefly earlier, Bill, the ability for your tools to scale across all of those platforms. Can you talk about how important that is?
Oh, most certainly. So, and now I know we keep saying we're going to answer Bill's question. So I think this is
this whole live stream is answering Bill's question almost.
Right. So, a good hardware, I would say, to start off with is like, for example, this little M0 device here, and if I cut to video for to see it actually running. Video 5. This is a M0 core, Cortex M0 core device. Is driving the like an OLED display, a black and white OLED display. It's capable of showing logos and text fairly clearly. So it's very low power too. So something like this would be a good starting point to actually help learn the tool itself, and then. As we scale up, you start looking at something like this the M7 device right here. This is an M7 device with a larger display, and this is if you can show demo 1 video, the video 1, yeah. Oh, actually it's this one. That's the M4 device that the video shown. That particular one is it's a M4 product, about a 180 megahertz device,
right?
And it's driving it's 320 by the 220 resolution display. It's got a capacitive touch, so it was one of the, I guess, the lower end devices that have capacitive touch. It's ideal for some sort of user interface where most of the time you're showing static images, not a lot of interactions. For example, say something like I guess a blood pressure monitor or something like that.
Right.
Yeah. So that would be an ideal display.
Something
for this
that'll
kind of
update every second or every couple seconds, right?
Yeah, exactly.
Okay.
Exactly. Now, what would be a versatile product, right? Is we keep talking about all these Cortex core devices. Well, Microchip has a lot of MIPS core devices too, and like MIPS core products that are. Wouldn't it be ideal if you have the exact same tool that can deploy to a Cortex device and to a MIPS core device?
Absolutely, it would.
Yeah, right. So this is where the versatility comes in. All these different displays, and you can mix and match them like it's like Lego itself, right? And then even more higher end, more exotic. And this, what I'm holding here, this is actually the MZDA device. That's our giveaway.
This is the giveaway
today.
right here.
This is a giveaway right here.
Ding,
this
ding, ding.
with the MEB2. This is the multimedia expansion board version 2 product. So this and if you can roll to the video, you can see that, wow, like you can even drive like animations, multi-layered animations with like high resolution, high responsive animations, and guess what? That little lamb game you see there is available to download for free as part of.
There you go.
Yeah, as MP Lab Harmony. So whoever if you get the giveaway today, you can actually have the software to run this already as it is.
It's the gift that keeps on giving.
Right. So with the slide we showed previously, we did not have this board and this demo on it, but this device, the PIC32MZDA, not only has the built-in microcontroller, so you're not taking that 5% hit on the microcontroller or having to use an external controller, but it also has a embedded graphics processor, which is enhancing your graphics because it is offloading some of the rendering functions.
That's right.
If the simplest device that you showed there was the Cortex M0 SAM-D21, the really simple device. That looks pretty similar to a lot of maybe like maker level, like hobbyist projects and things like that. If I have a project and as we mentioned at the beginning, the whole point of this live stream is how to enhance your product with embedded graphics. Is it simpler or more difficult or about the same or I guess the question is, how do I know, should I go for the most complicated thing first? Like, do I want to like get started right away on that MPU LAM game thing and then work my way backwards if I find out that, oh, it turns out my customer didn't actually need quite as nice? Or is it better to start off on something simple like the SAM-D21 and kind of work my way up from there as the design requires it?
I think the modularity of the software. So within our own software framework, you work with MPLab X, which is very well known development tool IDE, integrated development environment. You work with MPLab Harmony, which is the software framework that binds all of the functionality together, not just graphics, but all the peripherals, all the timing, all the setup and everything. Within it, there's individual tools that help you step by step to the point where really the only time that you're touching C code in depth is when you're writing your own top-level application.
Okay.
We try to abstract all the rest of that out in a very optimized, very efficient way. So with that, the reason I say all that is because I feel very comfortable that you can dive into the level of what your application requires.
Okay.
Because
cool.
there's so much there in terms of example applications, example sub-applications like functions, functional examples as well.
Okay.
And it's bound together by such an awesome set of tools that you can go in and enter at the level of the functionality that you need for your application. Would you
Great.
agree?
Yes. So that's exactly it. Is in terms of where to enter or how the tools, all these demos you've seen here, and actually there's one more demo I want to show too.
Okay.
Yeah. So this is a MPU class product that drives an even larger, higher resolution display. And if we can run demo reel number 4. Now we're looking at this is an MPU class product, and it's driving almost like a car dash type high performance display. So and this product is running at like 600 megahertz. And we've seen all these. We've seen everything from the little M0 OLED to now this MPU product. And guess what? You can actually use the exact same tool and the exact same skill set to do this. So the learnings you get from developing on this little maker device can translate directly to the rest of these products, and that's exactly. And I think Kurt, you can kind of go into talk about how that's achieved with our product, with our development tool.
Absolutely. I just want to touch on though, that's a microprocessor.
Yes.
And it's running off of or it's being developed with all of the same tools.
Okay.
That's right.
So oftentimes when you hit that limit, that top level microcontroller, 200 megahertz or 300 megahertz, that was it.
Yeah.
Now we've enabled you to develop into the 400, 500, 600 megahertz space with integrated graphics controllers, with integrated graphics processors, but staying in the microcontroller development environment that is, not only familiar with what you've done previously, but also continues to stay tied in with your lower end or your moderate level performance products as well.
Yeah.
So same development tool. Cannot restate how important that is, that you're getting into all of the microprocessor goodness, but not leaving your tool set, not leaving your experience. So that's super important. So actually, back to what you asked. You asked about the
tools.
The tools.
Our tools.
Oh, okay.
Yes.
So touched on this previously, but let me hit on it again. So MPLab X IDE from Microchip, that is our award-winning. It's our top level. Everybody's familiar with it. Everybody loves it. Integrated development environment. And so that's where you start, not only with all of the 32-bit microcontrollers, now the 32-bit microprocessors, but all the other controllers from Microchip. So your 16-bit, so your 8-bit. So if you're watching out there and you're saying, 32-bit's totally new to me, I'm an 8-bit, fantastic, we love you. Use 8-bit when you need 8-bit, and if you ever need to move, then you're in the same environment.
That's
you're in the same
incredible.
tool.
Wow.
Yeah, fantastic.
Okay.
So what you'll be moving into is MPLab Harmony. And MPLab Harmony is that software landscape, it's that framework that ties everything together, all of the peripherals, all of the inner workings, the setup, everything is worked within that. And so it's so important to know how powerful it is, but how easy it is to use. I think we had a graphic in the, let's just go to the next slide. Here we go. Great, I should be working off of this one right here. So, and then we get into, from MPLab Harmony, within that is the MPLab Harmony graphics suite. So these are the tools and the software and the applications that you'll be using to develop your graphics applications in any one of these demos that Bill's referred to. So actually, before we go into this, we have a question.
Yeah, it looks like we have a question in the
All right,
booth.
go ahead.
Let us know, Clifford.
Yes, we do. Rachel?
Yeah, so Jared was wondering where he can find examples and software libraries, things like that. So I think that's on our website. Can you guys point him in the right direction?
Yeah, 2 different places you want to go, and you'll see this also at the end. The main place that you want to go for everything graphics, microchip.com/graphics. There it is on the bottom of your screen, right down here. All right. Also, you can go to microchip.com/harmony if you're looking for software examples above and beyond just graphics to everything that you can do in the 32-bit space. I used to say the 32-bit microcontroller space, but I have to get used to now supporting the microprocessors, which is awesome.
That
really,
is.
really happy about that. So yeah, those 2 places right there. We'll hit it again later on in this live stream, but microchip.com/graphics, everything you need, especially not just where you can download all this fun stuff, but also where you can go to get to the wiki, to get to GitHub, to get to all the resources that you need as well to get started. Getting that first step off is so important, as we said earlier.
Right.
And that's the site you're going to go to get to there. So
Yeah.
there you go with that. All right.
Jared. Great
Thanks, Jared.
question.
Appreciate it. All right, let's go back to the slide. Thank you. All right, so within the Harmony Graphics Suite, there's 4 major components. All of these are going to be very useful to you. For GUI composition, graphical user interface composition, I know we talked about that earlier. It's our designer. This is where you're going to have a what you see is what you get interface, or WYSIWYG if you've heard of that before. And this is going to help your iterations go much, much faster, because you're going to be very well, you're going to be convinced that what you actually put on that screen, and then when you dump it over into the hardware, is going to be what is going to appear on the hardware. So there's no translation, there's no, yeah, almost, or looks kind of like it. And that's going to cut down the number of iterations, because you're going to be very, very accurate from the tool, not just from the hardware.
Okay.
All right, so that's going to be really, really important. The next thing is the library that you're going to work with. The runtime graphics engine, the software underneath everything that is being developed. So that designer, once you've got things in place, will pull from that runtime graphics engine and all of the code in the library to create what it is that you want to see on your hardware. And so to make sure that that is efficient and effective and doing what you want it to do, and doing it for the targeted hardware that you have, whether it's that Cortex M0 device all the way up to the Cortex A5 device, it knows exactly what libraries and what drivers to use, and will pull that for you. Then moving clockwise around to the drivers itself and the display controller driver. This is really important. So you notice that we have a lot of standard size displays, either the 3x4 or the 16x9.
Yep.
And those are pretty standard, and we have some drivers already built in. But what if you want to use a non-standard driver or a non-standard display?
Yeah.
What if you want to use something long and thin, or tall and thin, or something like that? That used to mean a lot of time spent writing C code and iterating that and debugging it and making sure it works. And oh my gosh, what happens if I get another batch of displays and they aren't exactly the same? So we've completely eliminated that. We now have a tool where you put in the specifications for the display right from its data sheet. So you should get the data sheet from the manufacturer.
Yeah.
And it creates the driver for you, all the C code, plugs it into the folders that you're working with in your project, and connects it directly back into the designer. So when you're doing that, what you see is what you get development. It is truly what you see is what you get for the display that you're using. So for instance, for this one right here, we plugged in the specifications for this display right here, and now you design in the tool off of this form factor.
Oh, wow.
Right.
Okay, that's
so
awesome.
Specifically to this form factor right here. And we can do that with any size display, and we have a number of developments that we've seen, our customers that we've seen that have used that to great success. So fantastic. And then finally, if we go to the final quadrant there in the bottom left, the configuration and the code generation and the configurator. So important here is that it works well together with all of the other components in your application. So we have tools that will not only configure the hardware for the graphics side, but we also have an event manager, because your application's not just, as you said, not just doing graphics for the sake of doing graphics. Going back to your scale example, you have to be able to detect that there's actually something on the scale substantial away, right? So you have to have that physical interface with the graphics interface that is alerting that it's now taking measurement. Now we have a tool that enables you to see, that enables the software to see this physical action or this physical response, whether it's from your A to D converter or an I2C, and tie it to a graphics response. I need to change numbers, I need to change background color, et cetera. And this event manager cuts down, almost completely eliminates the need to C code that together.
That's right.
Which is again another huge time saver. Huge time saver.
Just like, and for example, there's like a couple of years ago, or Kurt, you did a demo for this where you live created a GUI design and drived it into one of our displays, right?
Faster than you can get your pumpkin spice latte, I might add.
Right. And how much code did you write for that one?
Absolutely zero.
That's right.
I wrote none, no code whatsoever to get that display, and it had working buttons on it and everything.
Oh, that's awesome.
Yeah.
That's super cool. And that's like, I think that's what's really cool to me about all of this is that if I guess I don't have to worry about, because I think one of the things that you can look at all this hardware on the table and you can hear all the stuff that we've said over the last 40-ish minutes and begin to get really overwhelmed. Like, even though we keep saying, hey, it's easy, like, it can feel overwhelming with just the sheer breadth of information. And the truth of the matter is, there's always going to be a learning curve and there's always going to be a challenge when you ever try to start something new for the first time. And like, that's part of what makes it good, is that there is that challenge there. But anytime you can diminish that challenge, the better. And so the fact that I can go into one of these displays and all I'm really having to learn how to do is I can spend a lot of time thinking about, like, what do I actually want on my graphics, and I don't have to take a ton of time to figure out how do I get them on there. And so, and that scalability piece I think is really incredible. If any of you out there have spent a lot of time developing, you'll know that one of the biggest challenges, that integration piece and that scalability piece are huge, because if somebody comes down from the design part of your group and says, hey, we just found out that we actually need it to look like this instead of this due to any number of reasons, that can set you back weeks if you don't have that scalability and that integration piece really like worked out and really perfected right off the bat. And I know integration is also just another huge piece of, you have different business units, different groups that aren't really talking, and then suddenly they have to put everything together. And if there's not a really simple way, if you're not, for example, using the same tool, like, all of this can be done with an MPLAB X. And so my architect and my applications guys can write all the back-end code, and then I can go right into Harmony and I can get my display. And so all these different pieces starts to come together, and at the end of the day you're saving yourself a lot of time and ultimately a lot of money, because you have the capability to do that.
As Bill said earlier, there's no avoiding the iteration.
Right.
There's no avoiding the cycle. You're going to do it no matter what you choose, no matter what combination of tools and hardware and silicon you choose. You're, not even I get it done in the first time, the right time. So the best thing is to get all of the components together. That's going to get you around that circle the fastest. And get you to that top point, if you want to go to the next slide there, and choose the tools that you can use to get you to that purple square. Qualitative evaluation, that's basically, how about this? You got somebody looking over your shoulder that wants to see your design, and you press a button, you say, okay, how about this? And they say, okay, no, I need to move that pixel one to the left or whatever. Okay, so you go through that cycle again as fast as you can, using the tools. You press a button, now you're saying, how about this again? And the faster you can go through that cycle, the faster you're going to get your product out.
Right.
And hopefully the larger your salary and the more bonus, right? I mean, that would be terrific too.
There we go. Awesome. Well, I know we're getting a little bit closer to the end, and I want to make sure that if there's been any pressing questions or anything like that we get those answered. So I know you haven't flagged me, but we good? All right. Sounds awesome.
I wanted to say a shout out to Ed and Ryan for answering a lot of the questions in the chat.
Awesome. Thanks, guys.
Yeah, and if we didn't get to your question, send us an email at livestream@microchip.com and we'll forward it to the right
Just
people.
send us an email, say hi.
It'll probably be Ed and Ryan. So and yeah, so.
Awesome. Yeah, Clifford doesn't get many emails at work, so if you can just send him an email to say hi,
Make my day.
you would make all of our days. Absolutely. Great. Well, I know we were going to talk a little bit about the integrated graphics at the end, so if you want to jump over to that and just kind of the design cycle piece on that last.
Yeah, let's talk about the design cycle piece really quick, and that's with this slide. So this is a Bill's slide from earlier, but with a little bit more detail. And what I wanted to show off was where all of these tools fit. So the MPLAB Harmony Graphics Suite, or in this case it says MHGC on it, the composer where you're doing your what you see is what you get, design and implementation, that is all of that where you bring in your assets. Your asset is, it's a graphic, it's your logo, it's a picture, it's, it can be a widget being a graphic that's also you're able to interact with, so a button or a dial or a slider, things like that. It's where your fonts get brought in, that's another type of asset. So then you go into your design screen, you put it all together, make it look good, and then you tie the widgets and everything else in with whatever you've got going on in the background. I've got something to weigh, I've finished weighing, I am not at zero, things like that. Once you get to everything set up there, your display manager is going to customize your display driver for the display that you want to use, not just a display that you're stuck with, but it's the display that you want to use for your application. And MHC, or the configurator, which we didn't spend a lot of time on, that is to the entire design. When MHGC is to graphics, it takes all of the aspects of your design and ties them together, make sure everything's working well, make sure everything's working in harmony.
Yeah.
and then puts it into code for you so you don't have to do that yourself. And another often overlooked item about that is it puts it into code for you so that it's fully optimized and it's bug-free.
Oh, great.
Yeah, so you don't have to chase down bugs because you did your own C code.
Right. Just to, I can highlight more on this point. Without this tool, like taking that design, taking these drivers and manually putting it into, I don't know, in this case MPLAB X or any kind of IDE of your choice, it's intense. It's a lot of work, right? I'd say of every block in that iteration cycle there, this piece is the most the most time costly, because you've got code generated from the designer tool, you've got your driver code, and you got to put it in, and then you work it in, and you go through this loop, and you have this on your display. And now you're like, okay, now we got to make these adjustments on your display. Now you go through a loop again.
Right.
And every time you're going through, if you don't have something automated, it's painful.
If you think you're back at that top left and you hit the button, nothing comes up on your display, you're actually down at the bottom right.
Okay, that's right.
So getting through that with the least pain possible, and we help you through it with no pain whatsoever, because it just works. You know, the tool creates it and it just works. All of the other drivers are made specifically for our silicon, so they just work. They come together right out of the box, and it's efficient and effective for you.
Great.
In the runtime space, then the display driver APIs and widget screen APIs, a lot of that ends up being a part of our library, and then you access that to get a deeper understanding if you really want to get into it in the wiki and in the documentation.
That's right.
So you have that available to you. You don't have to, but you can if you want to. But finally, graphics on display, qualitative evaluation, otherwise known as, how about this?
How about this?
All right. And then finally, let's really hit this last one really quick. So the integrated graphics development, this is giving you more of a visual from the standpoint of the actual screens that you would see and you would make use of. So the display manager, I'm going to start in the top right. The display manager is that tool I was talking about earlier that helps you create the display driver for whatever type of display and whatever form factor display that you want to use. That display manager, I started with that because that feeds into the configurator, but it also manages the display you're designing to on the Harmony Graphics Composer on the left side.
That's right. Yeah.
So you're now working with the actual aspect ratio and the pixel sizes and everything else, or the number of pixels on a side for your design that you configured into the display manager. So the configurator brings in all of that information, ties it into the rest of your design and all the other functions you've got going on, and it speeds up the iteration through the combination of all the codes and handlers and drivers and everything else at the bottom, so that everything is automated. And the only area where you end up getting into handwritten code is into your application code.
That's right.
Which is that's your sauce.
Yes,
That's
exactly.
that's what's driving that preference, right? Once
Yeah.
you've got that creation in the graphics, what you're doing with it and how you're implementing it is your specialty. It's what you offer to your customers.
Awesome. Great. Cool. Well, thank you all so much for joining us today.
Absolutely.
Just kind of quick recap. We've covered a lot of information today. So we started out talking a little bit about why do I do graphics, and then what are some of the challenges? So challenges, like with everything, is like, where do I get started? Like that's the first big question you have to ask yourself. Right. And then we talked a little bit about tools and the just different demos that we have here available, and really the power of making sure that when you're getting started, you almost don't shoot yourself in the foot and pick an environment that does as much of kind of the busy work and the integration and that piece of it for you, so that you can spend as much time as possible actually figuring out what is the display going to look like and how do I change the pixel and things like that to fit my design needs, as opposed to figuring out like how do I integrate my code and things like that. We talked a little bit about hardware systems and what kind of a hardware system I'm looking for and some of the specifications to keep in mind with that. So how many pixels do I need? What kind of a microcontroller core is going to be needed to drive the display that I have? What pin count is that going to need? What kind of interfaces? So what kind of serial interfaces, whether that be a serial peripheral interface or I2C, I always forget what that stands for, or UART, or any number of other serial peripherals out there. And then what kind of graphics controller am I going to need? Is that going to be internal versus external? And Bill showed us a little bit about what the differences there are that you can have with that. What kind of am I going to need a graphics accelerator to do my project well? What kind of a frame buffer am I going to need to make sure that it's updating that picture fast enough and accurately enough? What kind of graphics reaction? What kind of frames per second? And how fast does my application need to boot up? And lastly, what's the power cost and the actual cost going to be? So those are all factors to keep in mind as you're kind of evaluating what display do I actually need. And then lastly, we talked a little bit about how do I actually evaluate the tools that are currently out there. So obviously, Microchip is just one of many different great tools that are out on the market right now. So as you're evaluating tools, making sure that you have a tool that does as much of the work for you is always important.
Right.
But then also, am I staying within the same environment? And the value of staying in the environment as you begin that process of integration and prototyping and going to the boss and saying, hey, how is this? And him saying, well, actually, I need the monkey on the top right instead of the top left, and saving yourself as much time as possible doing that.
Yeah, don't drive up that learning curve any further
Yeah,
than you have
exactly,
to, right?
exactly.
If you
No, I
can
can
stay with what
definitely-
you know, stay with what you know. It's
Absolutely,
faster.
totally. Well, great. With that being said, I think we have a prize winner, not some prize winners, a prize winner in the back. Rachel and Clifford, do you want to tell us who that is?
We would love to.
Sure. So first, I just wanted to reference Steve Ritter made a comment in the chat asking if there are any plans for a live stream about using Qt for integrating graphics displays. And we didn't before you made that comment, but now I think we definitely are going to discuss that. So thank you. So if you and anybody else has suggestions for other live streams, put it in the chat or send us an email.
Or comment. That would actually be the
comment.
best place to put it, is if you put it in the comments there. We definitely keep track of those and use that as one of the sources of coming up with new information.
Yeah, so sure, yeah, definitely. So put it in the comments too. And then the winner of the PIC32 MZDA starter kit with multimedia expansion kit is Multicrafter. That's the handle. I'm not sure what your real name is. But congratulations. So send an email to livestream@microchip.com with your shipping information, and we will send that out to you.
Absolutely. So we'll need a phone number, your name, and just your address. And if we can't ship to you, we apologize in advance, but we'll try. Yeah.
Awesome.
All right.
Make sure to like, comment, subscribe, and hit the bell for notifications on whenever we go live so you guys don't miss any more of these. But thank you very much. Back to Matt.
Yeah, thanks, Clifford. Bill, Kurt, thank you so much for taking time out of your day to be with us today.
My pleasure. Thanks for
and
having us.
To share all this incredible information. Once again, make sure that you are liking and you're following us. Subscribe to all the great information that we have out there. And with that, I think that's a wrap. So have a good day, and we'll see you back. Oh, one more thing. Next live stream, we're going to be talking about touch, actually. So today, there's like this whole realm of human-machine interface, and one big aspect of that is graphics, which is what we talked about today, but another big part of that is touch. And so next live stream, we're going to be talking and having some of our touch group in here to talk about how do you implement touch control in an embedded project. So that's going to be awesome.
That's the group that did all the touch on our demos. So
There you go.
every demo, there's really just one demo that doesn't have touch on it.
Okay.
You're going to hear about from the group that created the products that created the touch for our demos. So
Perfect. There we go. And on that note, have a good day. Keep that prototyping up, and we'll talk to you real soon.